Newton's second and third law of gravitation. So according to Newton's third law of gravitation, every object attracts every other object with a certain amount of force, but the forces are equal and opposite. For every action there is an equal and opposite reaction. Yes, no? So this is Newton's third law, and Newton's third law of gravitation states that let us consider two objects, that is Earth and Sun. Okay, so Earth is revolving around the Sun. So Earth is giving certain force to stay in the orbit. Similarly, Sun gives the equal amount of force to make the Earth revolve in the orbit. So each force are equal, but they are opposite. So this is Newton's third law. And Newton's second law will be like, so let us consider a case. What happens when a ball is dropped from a certain height from a ground? The ball is seen falling towards the earth, but the earth is not jumping, right? So according to Newton's second law, F is equal to mass into acceleration. So F is equal to mass into acceleration. So we can relate it to third and second law as well in gravitation. So next comes what is meant by free fall. So free fall is nothing but, let us take an example. What we can take is a body having a free fall is called as free falling body. So let us take an example to identify. So to identify what is a free fall motion. Okay, so imagine a vacuum is created by evacuating all the air from the jar. Okay, so let us consider a glass jar in which all the vacuum is evacuated. Okay, so inside the glass jar we are having a feather and a coin. We made them to fall with the same acceleration, and they reach the ground at the same time. So what you notice from this point, feather and coin both are reaching the ground at the same time. Feather's mass is less when compared to the coin's mass, but in this case, since there is no air, since there is no external force, it only depends on gravitational force and falls down. This is called as free fall condition. So free fall definition is when a body falls from a certain height towards the earth only under the influence of gravitational force. So this is called as free fall. Okay, free fall. So now let us discuss about acceleration due to gravity. So acceleration due to gravity is very simple, and it is denoted by the letter G, small g. Okay, small g. So acceleration due to gravity is defined as the uniform acceleration produced in a free falling body due to acceleration due to gravity of the earth, and the value of g is 9.8 meter per second square. And how to calculate the acceleration due to gravity? We can take the universal law of gravitation, F is equal to g mm by r square, and according to second law, F is equal to m into g. So instead of F, we can put as m into g is equal to g mm by r square. So small m and small m will get cancelled, and the formula will be like g is equal to gm by r square. Okay, so in this, m is stated as the mass of the earth. So mass of the earth, the value is 6 into 10 to the power 24 kg, and the radius of the earth is 6.4 into 10 to the power 6 meter. When you try to solve this small g, you will get the answer as 9.8 meter per second square. Okay, for the simplified calculation, we can take g as 10 meter per second square, and also we can say as the acceleration due to gravity is different for different planets. For Earth it is different, for Moon it is different, as acceleration due to gravity depends on the radius of the planet. Okay, so you'll have a question like, what will happen if the acceleration due to gravity at the center of the earth? Because as we told, the acceleration due to gravity on the surface of the earth is 9.8 meter per second square. At the center of the earth it will be 0, that is at the equator it will be 0, at the poles it will be maximum, at the altitude means above the poles, it will be decreasing. Okay, so acceleration due to gravity decreases with altitude, acceleration due to gravity decreases with depth also, acceleration due to gravity will be greater at poles. Okay, will be greater at poles. So this is about acceleration due to gravity. And next we will